Part 2, Exploring Data Numerically. So, summary statistics attempt to describe a data set with a central or typical value and an indicator of how much variation or variability or spread exists. Okay, so typical measures of center, you might have heard these in high school: mean, median, mode, right? Mean is the arithmetic average, it's calculated. So you add up all the numbers in your data set and you divide them by the number of values. Or simply the X with a bar. So X bar, that stands for mean. It's the sum of all your individual X values, your data values. You add them all up from 1 to n. Oh, this is missing divided by n. All right, so I'll have to update that. So it's the sum of all the individual data values divided by n. The median is another measure of center. However, it's not calculated. It's a location. All right. It's a location such that half the data are below and half the data are above, 50% and 50%. The way you find the median, not calculate, but the way you locate the median is you place your data in ascending order, least to greatest, or could be descending order, it would work the same way. But usually least to greatest. If there's an odd number of numbers, there's a middle. Think about 5 people standing in front of the room. The third person is right in the middle because there's 2 people to the left and 2 people to the right. Okay, so if there's an odd number of numbers, n plus 1 divided by 2 will find you the location of the median. All right, so if you have 5 people, 5 plus 1 is 6, divided by 2 is 3. The third person or the third data value would be the median. If there's an even number of numbers, there is no middle value, so it's going to be between 2 values. Okay, so if you had 4 people standing in the middle of the room, there's no middle person, but the middle would be between the second and third person. So that locate the median when there's an even number of values, you take n divided by 2 and n divided by 2 plus 1. And the median is between those two. All right. The mode, which is the least useful in most cases, is the value that occurs the most often. And there may be no mode. If you had a set of data where there were no repeats, there's no mode. But you also might have multi-modes. You might have bimodal or multimodal data as well. Mean, median, mode, those are measures of center. Then you've got measures of spread or variability. All right, so you have the range, which is the maximum minus the minimum. That'll give you the entire span of the data. You have what we saw in the last video, which was interquartile range, the IQR. It's the middle 50%. So it's the difference between the upper quartile, which is the 75th percentile, and the lower quartile, the 25th percentile. If you subtract those, Q3 minus Q1, you get that span of the box in a box plot, which is the range of the middle 50%. Okay. And the reason why we care about the middle 50% is because most people, most things, most measurements are average. And so you want to not dwell on high or low outliers, right? Unusual measurements. So if we focus on the middle 50% of the data, we get a better idea of what is typical, not extreme. Variance and standard deviation, these two kind of go together. Okay, the variance is difficult to kind of understand on its own. It's the average squared difference from the mean. So you take all your data values and you subtract them from the mean to find out how far they are from average, and then you square that, which is multiplying it by itself, and then you take the average. Now, why you would square the difference is to make everything positive so that negatives don't cancel out positives. All right, so there is a method to the madness here, but variance on its own is kind of difficult to understand. I prefer to think about the standard deviation, which is where you take the variance, the average difference from the mean, squared, and you square root it to undo the fact that you squared it. Okay, so this is the standard deviation is the average difference from the mean. So on average, how different are values from the mean? Okay, it's a really powerful measure of spread. It's the average deviation, the typical difference from the mean. If you have a small standard deviation, that means that the data doesn't differ on average from the mean, so everything's clustered together by the mean. So you have very little spread. If you have a low standard deviation, the data is not spread out. It clusters towards the mean. If you have a large standard deviation, that means on average, the data differs in a large way from the mean. So the data is very spread out. Okay, and this is the formula. You don't have to memorize this or know this. We're going to use technology to get the standard deviation. So don't freak out and faint because you're seeing this. But it's basically the sum of all the differences from the mean. This is value minus mean squared. Add all those up and divide by n minus 1, which gives you the average when you divide by the number of numbers. The reason we're subtracting 1 here, that's a technical adjustment that we make for sample data. Okay, this is actually us adjusting a little bit. We're subtracting 1 to err on the side of caution. And mathematical models and simulations have shown that by doing this little subtraction by 1, it actually improves our accuracy of calculating the standard deviation for a sample. If this were population data, you wouldn't do that. So not something to really worry about. Just know that the standard deviation is the typical difference from the mean. So if the standard deviation is 3, that means on average, data differs from the mean by about 3 units. Okay, small standard deviation, small spread, large standard deviation, large spread, and don't worry so much about this formula. Okay, oop, let me go back there. We had one more thing. How do you determine if something's an outlier? This is one definition, but these are kind of rules of thumb. There is no way to really, we don't all agree on what an outlier is, but this is pretty widely used. The 1.5 IQR criterion. So if data is more than 1.5 IQRs, which remember that was the range of the middle 50%, below or above the quartiles. So we make these cutoff values. Okay, but again, these are not something that you have to memorize. This is just what's used. My favorite way to determine outliers is to look at a box plot like we did in the last video, and you can see the outliers as floating dots. So you don't really have to calculate them by hand, but we will eventually. Okay, and some important observations about when you have symmetry versus skew. The median and the IQR, listen up, this is very important. The median and the IQR are resistant to outliers and skew. So when you have outliers or skew, the median and the IQR are the best measures of center and spread. Okay. Why is that? Picture everybody sitting in a restaurant, right? And you want to know what's the average bill that's being paid, right? Well, if you had an outlier, so if somebody was going all out and buying really expensive bottles of champagne and the seafood tower and the surf and turf, and they were really spending a lot, and so their bill was way higher than others, the median, the middle amount, would not actually be affected by that. Okay, the middle amount would not be affected, but the mean would, the average would, because you'd be including that large amount, that high outlier, in your calculation. But the median is not a calculation, it's a location. So just adding a high or low outlier doesn't really affect the median or the IQR. Okay, so when you have outliers or skew, you should use the median and the IQR. When you have symmetry, when everything's roughly symmetrical, the mean, median, and mode tend to line up in the middle anyway. So the mean and standard deviation are best when you have symmetry and no outliers. Okay, let's do an exercise. So this is going to link again to the notes, which I think I have open already. So I'll just go to those. Okay, so here's our notes, and if I keep going down, here we go. Here's exercise 2.2. So we're going to do this together, and I'm going to copy this and paste it into my note sheet here. All right, exercise 2.2. Let's look at the same data on community college enrollment. Calculate the summary statistics. Okay, so summary statistics are mean, median, mode, variance, standard deviation. So I go back to Staplet, and I already have it. So I would do the same thing I did. So rewatch the last video if you don't remember how I kind of got this analysis here. And here they are. Here's the summary statistics. So you could actually screenshot this, or I might even be able to copy and paste it into my document. Let me try that. Or you could export it to Excel. Okay, yep, that didn't really work. So I'm going to screenshot it instead. And if you don't know how to screenshot, just Google, how do I screenshot on my Mac? How do I screenshot on my Windows 11 or whatever computer you have. Oop, that's not what I want to do. So I screenshotted that, so I'm going to insert image. This is something you should get good at, is screen capturing and inserting into a document. That's just good for any class you take, not just this class. Okay, it's not fitting on that page, but that's okay. So here it is. I might want to get rid of this like graph type here, so I'm going to crop that out of it. There we go. That's better. Again, just Google how do I crop. Yeah, okay, so I'm going to keep that there. Oh, wait, that's not what I wanted to insert. That wasn't it. I wanted the summary statistics. Maybe it wasn't there yet. There it is. It should always be the most recent. So I'm going to shrink that a little bit. Perfect. That looks really good. Okay, there's the summary statistics. What does each number tell you about the enrollment in the college? Okay, so let's start typing down here. N is the sample size. That doesn't really tell us anything, but I'll write it anyway. N, run a lowercase n. N equals 35 tells us there are 35 community colleges in the sample. Okay. The mean, which is x with a bar over it. I wonder how to do x bar. Let's see. Let me highlight this, and I might try to insert a symbol or something like that. Let's see. Let's learn together. Insert equation. Let's see, where's the equation editor? Here it is. All right, so let's see if I can get a little... there it is, x bar. I found it. Okay. So x bar. I'm going to hit tab to kind of get out of that equation editor. X bar equals 86. Now, if you're no good with technology and you can't figure out how to get an x bar, you could just write mean equals. Okay, you don't need to use the fancy schmancy symbols. X bar equals blah tells us the average enrollment in the sample is about 8,629. I'm going to round up students. Okay, that's the average. The SD, which there is no symbol for that, it's just SD, standard deviation, which is 6943.885, tells us the average enrollment differs from the mean by about 6944 students. Okay, so again, the standard deviation is a measure of spread. Okay, so on average, enrollment differs. So I shouldn't say the average enrollment, I should say on average. Tells us that on average, this is phrased better, enrollment differs from the mean by about 7,000. So what that means is the average is 8,600, give or take 7,000. Okay, so 7,000 is the typical deviation. So this is fairly spread out. Okay, this is a pretty large spread or variability. Okay, so if I randomly select a community college, it's likely that it's going to be within 7,000 students of this, of 8,629. Okay, so it's the average deviation from the mean. So there's a high deviation from the mean. The minimum. Minimum just tells us the lowest. So the minimum is 1263. This is the smallest community college, by enrollment anyway, in the sample. Don't say in the world or something. I'm going to do the max too while I'm doing min. The largest was 28,165. This is the largest by enrollment. Ooh, how many M's in community? In the sample. All right, now we'll talk about the other things. So the Q1 equals 3,200 is the lower quartile which is the 25th percentile. Okay, this tells us about 25% of community colleges, I'm going to say CCs, in the sample had enrollments less than 3,200 students. Okay, and let's go to the median. All right, so the median is 6414, is the 50th percentile. Okay, this tells us about half, about 50% of community colleges, CCs, in the sample had enrollments less than 6414, while the other half had more than 6414 students. Okay, and then Q3 is the upper quartile. What was that? 10,012. 10,012. You could use commas for thousands. I'm just not. This is the upper quartile, which is the 75th percentile. Okay, this tells us about 75% of the sample, of community colleges in the sample, had enrollments less than 10,012. So only 25% had higher than 10,012. What else would I like to say? I might say the interquartile range. I might add that here. Okay, some other ones. The IQR, interquartile range, which is the middle 50%. Okay, so the way you calculate it is Q3 minus Q1. All right, so that's going to be 10,012 minus 3,200, okay, which equals, so I'm going to go to my favorite calculator, which is Google. 10,012 minus, what was it, 3,200? Hit enter, and Google is a calculator. You didn't know that. 6812. Okay, this tells us the middle 50% of community colleges differ by or span 6,812 students. Okay, so the middle 50%. So there's only a span of 6,800 students in that middle 50%. That's the IQR. I can also tell the variance, which again, I explained before, is not very helpful to know on its own, but it's the standard deviation squared. But it's going to become more important or more useful later. Okay, so the variance is, standard deviation was 6943 right here. I copy and paste this number, that's the standard deviation. So if you copy this, paste it into Google, and just hit times itself, use the asterisk for times. This is a huge, huge number, but that's the variance, which on its own, not very helpful, not very useful, but it's something, it's a number or a word that you should start recognizing. All right. I think this was, I don't know, Times New Roman 12. All right, and now something that I can tell, another thing I can tell, remember how this had outliers and some right skew, right? Look at the difference between the different measures of center, right? Median and mean are both measures of center. The mean is 8,600. The median is 6,400. So the mean is much bigger than the median. Okay, and that's because they're both trying to measure the same thing. The reason the mean is so much higher is because of these outliers that are high. They're pulling the mean to the right, and because of the skew. Okay, outliers and skew pull the mean in that direction, which is why we call this right skewed, because it's got that right slope that's kind of pulling the mean to the right, whereas the median isn't there. So the best measure of center, right? Because of the outliers and skew. And I'm going to say and or because either one of those tells us to use the median. Because the outliers and skew, the median and IQR are best measures of center and spread, okay, or variability. I say spread, but which is kind of casual. Variability is a better statistical term, all right? But you might hear me say spread. So these are the best measures. I'm going to highlight those. All right, so if I was writing out a nice description, these are the ways I would describe the center and spread.